Got to do something there. All right, now I got this working up there correctly. Let me actually pull up our curriculum. Let's see, 0A. Wonderful software development. Programming 2. Okay. All right. So let's take a look at what we got this week. I haven't, and it just seems like everything's going swirling around. And I get a new computer today, and I'm waiting to see when he comes in because it's like, okay, I can't get a new computer right now. I'm in class for the next couple hours. So, but it's supposed to be a new one coming, and so I'm going to replace this thing with something. This is about 5 years old, which that's not bad. But as heavily as we use the computers here in virtual, it's probably time for a better, faster one. So, all right, let's go to our grade screen. See where we're at here. We have finished data structures last week, 1.03, and this week we're in documenting and debugging. Oh, and next week we're going to finish this module. So we got the exam over this lesson, this whole unit next week. So let's go look at 1.04, see what we've got going on there. Oh, I jumped all the way out. Documenting and debugging lesson. Planning, not optional. If your favorite app has ever crashed or a program you use just wouldn't load, you may have fallen victim to a programming error. I mean, errors do happen, but they happen a lot less when you make a plan and stick to it. You have an idea, you turn that idea into a plan, and you turn that plan into an action. So when writing a program, a proper plan should include pseudocode. Write code in simple English. Focus on the logic, not the syntax, not the code. And then check if someone else can read your pseudocode and understand the process that doesn't know anything about programming. After that, you take that plan and you translate it into actual code. Right? Take your pseudocode and actually say, okay, what do I need to write to make that happen? Use pseudocode for internal documentation to inform and explain, putting those comments inside our program. And then we debug and check for errors. Next, simplify. Look and see, did we do stuff that we really didn't need? Do we put extra steps in there, extra functions, extra variables? It's like, really, I didn't need even need that line. It really doesn't do anything. Let's simplify our code so it doesn't get all garbaged up. Ensure your variable names are something meaningful. And again, debug and check for errors. And then finally, the post-mortem review. Get feedback on our program. Know how it can be improved. Understand how it's useful in other situations. So consider the scenario. You are a programming intern at the local animal shelter. So your manager wants you to finish off a half-written program for the shelter's website that features a different adoptable dog each week. So someone started writing this program and they left. So as you review the existing code for the program, you discover that an important piece of code is missing. The code that features the special dog each week. They didn't write that. So if you'd sent the program to the web developer without discovering this error, a poor puppy might have never found his forever home. Oh, they're being cute. Yeah. Remember, as a programmer, it's up to you to make sure your code uses easy to read internal documentation and is free of errors. So let's work through this Python guided activity to practice our planning, documentation, and error detection skills. All right. By the way, I got a new monitor last week, so this is a different shape. So I have a wider monitor, and mine last one's about square, so it probably appears a little different on your screen. But looks like we can get the whole Python guided activity. And I was worried about that with the shorter, skinnier, wider monitor. Read the code, try to predict the output, select run program. There is a runtime error, so something's wrong already, we know. Error in an animal shelter code. Define main. Hashtag input dog breeds. Okay, so first thing they did is created a list with their breeds. The Chow, the Boxer, the Beagle, the Bulldog, the Poodle. Length equals. Well, yes, we can certainly see an error there. They didn't finish that line of code. Calculate how many of these dogs are available. Print there are string length animals currently housed at the rescue center. So when we run it, yes, we certainly see there's an error because length equals was not completed. Invalid syntax. There's the actual name of the error. So Obviously, we want the length of the dog breeds. Do you remember the command for length? We did look at that already this year. We've pulled that up. And if we don't remember, we can always go to the reference section. Let's do that just for grins and giggles, even if you do remember it, just to refresh ourselves on how this works. Just click on the reference button. This opens up. Let's see. Let's go to lists. Append index length. It's right there. So if we want to find the length, we use the len command with parentheses around the name of the list. So using our reference section, we can say len parentheses dog breeds. So that should give us the length. There are 5 animals. Perfect. Oh, it says your code runs. What did they not want? But that's not quite the output we're looking for. We did use the len function. Why do they not think that's what we were looking for? I have no idea what they're looking for because that does what they said. So this is kind of odd. len dog breeds. Yeah, there couldn't be anything else that goes there. They don't want a space. I just wonder if I didn't put a space if that does it. Yeah, good. Look, I didn't put a space and it says now it's perfect. We know that they put a space in front of the equal sign, so putting a space after the equal sign just makes it easier to read. And Python doesn't care if we put a space in there or not. But okay, that's just weird. Slide 1 of 2. So there's another one here. Read the code, try to predict the output, select run program. All right, so the first part of this program, dog breeds is the same list. Input weeks in the shelter. So we've created another list showing how long they've been here. The Chow's been here 1 week, the Boxer's 3 weeks, the Beagle's 5 weeks, the Bulldog 2 weeks, the Poodle 4 weeks. There's that length dog breeds, just like we typed it. Calculate how many of these dogs are available. Oh, how many? Yeah, okay. That's the 5 animals currently housed. And display featured dog using index position. The week 1 featured dog is. Well, when you run it, this is a runtime error. It's not a syntax error. There's nothing wrong with the code, but it doesn't do what we thought it should do. Week 1 featured breed is. There was never any dog. This is where we learned they didn't finish the code to say what the featured dog was. So the last programmer started this code and didn't finish. Can you fill in the missing code using the comment provided? Display featured dog using index position. So let's see. Chow is going to be featured in week 1. So we need to use the index position 1 or 0 because he's the 0 dog, right? Week 1 featured breed is okay. Let's do the plus dog breeds, and then we use the index to say I just want to pull the 0 position dog out. Chow, there it is. Let's see. Oh, they wanted it on a different line. That's why they didn't like what we did. They think, okay, I just thought it'd be better to put it right there, but they have it like this. They have a separate line altogether. Print parentheses dog breeds. Yeah, they want it underneath there. Good job. You discovered the missing code. I like it on the same line with this, but either way is correct. But Buzz is just kind of picky here in the way they're looking for it. They're making it simple by putting it on the second line. Now, interestingly enough, they didn't use this for anything else yet, but tracking that, as they add onto their program, they'll probably would want to use it somewhere. Hey, the Chow's been in here for 1 week. And when they get to the Beagle, they'll say, "Oh, he's been here, over 5 weeks. Come make him your forever friend." So, all right, that's all of page 1. Let's go to page 2. Explain yourself with comments. So have you ever put something important in a safe place only to forget a few days later where that safe place was? Yeah, it happens to me all the time. I'm like, okay, where did I put that? So I've got a new strategy now. When I go look for it and I don't find it, when I do find it, I put it in the first place I looked for it. It's like, well, this is where I looked for it. This is where I thought it should be. So that's where it's going to move to from now on. Yeah, we've all done it. Jotting down a reminder usually helps. Like you could have a whole board of these reminders. That's why writing comments in your code is important. In addition, more comments usually translates to fewer errors just because you're making sure you get everything done. So in Python, comments begin with a hash mark or a hashtag or a pound symbol or whatever you want to call that. Some people call it the tic-tac-toe symbol. Right? Continues to the end of the line. As programs become longer, comments help you remember easily forgotten details about why you coded something a certain way and helps you prevent errors. This will help you and any other programmers you might be working with. So comment like the pros. Start commenting as soon as you begin a new program. Of course, we do. We put our name, our date, and the purpose of programming right at the top. But use the pseudocode to guide your comments. Your pseudocode may actually end up being your comments. You may just use the exact same thing you wrote in your pseudocode. Continue to comment as you write or update a program. Use comments to explain why you coded a certain part a certain way. If you did something that's a little bit tricky, put that in your comments so people can understand it. Other programmers can pick it up where you left off and know what you were doing. Place comments at the same indent level as the code that it's commenting on. That's a good plan right there. Yeah, if your code's indented, your comment above it should also be indented, just so we know what your comment is about. Comments and variables: the good, the bad, and the useful. Oh, we don't have the ugly. Oh, that's all right. Not everyone writes meaningful and useful comments. Don't be that person. You don't want to be that person. Make your comments and variables meaningful by the following do's and don'ts. Your future self will thank you. Why, thank you, me. You're welcome, me. Do's and don'ts. Do include useful information that's not in the code, like V equals 5. Hashtag comment speed in distance divided by time. All right, so that's V equals 5. It's explaining what this is. Don't state the obvious. V equals 5. Assign 5 to V. Yeah, I think the programmer understood that. I think we knew you were assigning 5 to V. But why? This is a much better comment. Let's see what the next one is. Use block comments if you have a long or detailed comment. And what they mean a block comment is we could have put all of this on one line, right? We could have just kept typing here. But since Python doesn't wrap, you'd have to scroll to the right to read the whole thing. So block comments mean when you get a few words, stop and go down to the next line just so we can see it all on the screen at the same time. We don't have to scroll over to get it. So that makes it a lot easier to read and a lot handier. So if you have long or detailed comments within a program, Python will not automatically text wrap. So block comments make it easier to read within the program. Block comments are usually used to give explicit details about your code, often written for people you're collaborating with. Right? Yeah, because if you're teaming up and writing a program, it helps to do more explanations of the part you're writing, so the other programmer can look and understand it. Don't use triple quotes to create multi-line comments. This will be treated as a string, not assigned to a variable. They'll also be removed as part of the garbage collection process, a feature in Python that cleans up unused memory as your program runs and frees you from having to manage details in your code, and not ignored like a correctly written comment. Like this appears to be a multi-line comment, but it is not. So apparently this is another way you can do that, but it's not really as useful and can create some problems. So don't do comments with like 3 hashtags, which makes me want to see what that does. Let's just pull up and do, instead of a hashtag, 3 quotes it's saying. I wonder if it treats that like a comment. Okay, how come you're not loading? Let's do this again. There we go. So I know I can do hashtag Mr. Brock, but can I do quote, 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 Mr. Brock? I should capitalize my name. Run program. Nope. Invalid syntax. Triple string end not found. Oh, if I put a triple now, oh, it counts that as a quote as well. But that's a lot more typing. Why would I do that as a comment when I could just do this? So I see why it would clean it up as garbage, collection there, because that's adding a lot more memory to do the same thing. So, okay. Yeah, don't do that. And I guess if you put the quote, quote, quote in the next line, that's when it creates a problem. It'll do an error here because it didn't have this at the end. But don't do that. Meaningful variables make your code easier to read and understand. Always make sure your variables begin with a lowercase letter. And if you abbreviate, explain yourself with a comment. Like, do keep variable names short, descriptive, consistent. Like voter name, voter party, poll location, voter street, hashtag the state the voter lives in. Oh, that's state, not street. See, I thought it was street. So the comment helps explain, no, this is the state. Good comment. Don't make variable names random, long, or confusing. Why voting is good. Party name. We don't need party name. We just know the party. If you're talking about voting, when you talk about the party, you know that's talking about the name of the party. Where do you go to vote? And voter ST was confusing because, again, I thought it was the voter street. We're looking at the street address where they live, and it's actually the state. So, good examples, good and bad, for your variable names. Oh, programming spotlight, a nun who broke all the rules. Oh, a naughty nun broke all the rules. Sister Mary Kenneth Keller may have led a humble, faith-based life as a nun, but that never stopped her from breaking down barriers. In 1965, she became the first person, either male or female, to earn a PhD in computer science. Prior to that, she worked in the National Science Foundation workshop at Dartmouth College, where she helped develop BASIC, which is a high-level programming language still used today. That's what I studied in high school. Instead of Python, I learned BASIC first. This is the person that developed it. At the time, Dartmouth prohibited women from studying in its computer department, and yet she got the first PhD of anyone. Later, Sister Mary founded the computer science department at Clark College and served as its director for 20 years. Today, it's known as the Keller Computer Center, named after its visionary and forward-thinking founder. Well, that's pretty cool. They prohibited women from studying, and she ended up getting the first PhD of either a man or a woman. So, certainly broke the rules. Naughty nun studying today. Error messages. You're not a real programmer unless you've encountered an error or two, or 100 or two. Errors or bugs happen. Here are a few strategies to identify and fix them on your own without becoming frustrated, because it can get frustrating. Syntax errors. These are the most common errors when learning to code, and they occur when you've broken a programming rule, one of the languages of programming. Python has rules just like other languages, which include spelling, grammar, and punctuation rules. Like you could have a missing parentheses, missing quote, a capitalization error. Like if we capitalize print, it's not going to work. It's going to give us an error. Print cannot be capitalized. It's one of the code words. Spacing and indentation errors. Then there's exception errors. Exceptions are unexpected problems that occur after you create and finalize a program. Python can identify and catch certain problems and continue to proceed normally. This is called exception handling. Code that tells a program what to do when an event disrupts the normal flow of that program's instructions. Excuse me. So this might happen if a user enters a 7-digit phone number when the program requires a 10-digit phone number, for instance. So in this case, the program will alert the user in easy to understand language, please use a 10-digit number, rather than in complex computer language like error, bad input. We've seen the syntax errors give it the error in computer language, but exception errors, it'll use nice, easy to read sentences. Examples, if you try to divide by 0. Oh yeah, I've seen that, and it does treat that nicely. Let's do that. Print 13 divided by 0. There's the error it gave us, division by zero. See, it didn't do that in some kind of fancy syntax error line 40. It has some of that up here, but the error it says is division by zero, which like, yep, can't do that. Attempting math operations with a string variable. Right. If we're trying to divide Mr. Brock by 4, that doesn't work. Doesn't work. Opening a file that's missing. Opening a file for writing when it's read only. So let's look at this real quick. So Python guided activity, read the code, try to predict the output, select run program, and follow the prompt. Okay, so we see a comment, we see our main function, we see a variable, and it's set to be an integer input and the end of the main function. Let's run it. Enter a number between 1 and 10. Let's give it a 7. Okay, that works. But what happens if the user enters something else like a string? Well, let's do that. What if I said 7? I typed that out. Uh-oh, boy, the errors are really huge. Invalid literal for integer with base 10, and I typed 7. So, boy, it really threw a big fit about that too. Let's look here. All right. This program asks the user for the voter ID number. Now, that would not be a math function. A voter ID number, we're not going to like add those together or anything. So we're talking about a string. This is a string literal. Define main, try. Oh, here's a new command we haven't used before. Try colon voter ID equals integer input. Enter your 6-digit voter ID number, except value error. So that means try this, but if you get an error because they enter something that's not valid, then do this. So we tell it what to do if they enter something. We say, okay, try this and see if they enter the right thing. Interesting. Okay, let's go back to our 6-digit number. Let's do 1, 2, 3, 4, 5, 7, just to be weird. And that's fine. But if we enter, I wonder if we entered just 7. Would that count that? No, that's still an integer. It's happy with that. But if we entered, I don't have one. Instead of giving us those 8 lines of errors down there and saying, didn't enter an input, it just goes to this line of code here. It says, if there's a value error, just print this. Don't print all of that Python stuff that we saw a minute ago, because on our program here, if we input something weird, it gives all these lines of errors when we have something it doesn't like. This tells it how to handle an error. So this is cool. Using try and accept to handle errors. So this, I'm just betting we're going to have this in our program, but we'll see. Try and accept value error. All right, slide 3. This asks for the voter ID number. Select run program, review the output. Are they what you expected? Try again. Here's the same code. It says, all right, if they enter something wrong, then we'll say this. Else, so it's kind of like an if then else program. Print, you may now vote. So if they enter something that's valid, then tell them they can vote. And that's the end of the program. So let's run this again. If I enter 7 as a word, it defaults to here. But if I enter 1, 2, 3, 4, 5, 7, it defaults to here. It goes down to else and says, yep, it's good. We tried it. It was good. So we don't need the value error line. Just go down here and say, good, you can now vote. Thank you for your number. You're good to go. This is pretty cool. I wish we'd have known this last year. Oh, well, it's a programming 2 thing. Handling errors. They misspelled handle. Handling errors with try and accept. Define main. Okay, try. Number equals integer input. What number should we divide 50 by? And then print what the answer is. Oh, and there's a comma in there instead of a plus. I guess we can do a comma instead of a plus because we've been using plus to concatenate. Unless it gives us an error. Except, and here's a value error, you haven't entered a valid number. Except, and now we're calling out a specific error, the 0 division error. If it's that, we don't want to say you haven't entered a valid number. We want it to say you can't divide by 0. So this, it can default to this for any error, but if it's this specific error, we want to say this. Now it's interesting. I would think you would put this first. So it checks that first. If it's not that error, then it defaults to this. But I wonder if it works this way. Like I say, this is new. Let's run this. Let's divide it by 6. Okay, that works. So it gave us total equals, and it automatically put a space in there. That's interesting because there's no space between our equals and the quote. So I wonder if that was a plus, how it would work. Oh, it gives an error. Oh, because we'd have to do the string thing. String, that's a string. So if we said 6 now, does it work? Yes, but it puts it right up against there. Okay, so we don't have to use the string to print a number on the same line as this if instead of this plus string thing, we put a comma. The comma means it doesn't care that this is a string and this is a number. So we're learning something right there when we say that, and it automatically puts a space in between the results and the last thing it printed. Okay, except value, you haven't entered value number. Oh, so let's go back to the divided by 6, and I type the word 6, and it says you haven't entered a valid number. How about when I say that's 0 that we have an error built for? Yeah, it skipped this because it looked at this specific error and said, oh, you can't divide by 0. So we can code specific errors. I wonder if our reference has errors that you could have. Like you may have to run it and find out what that error version. Yep, comments, if else. Nope, I don't see errors on our reference. So you may have to get this error before you can code that. Or we could probably Google up a list of Python error codes. All right, let's look at slide 5. Adding an exception. Okay, yes, we want to learn more about how to do this. Try number equals integer input. What number should we divide 50 by? Print the result. Except you haven't entered a valid number, the except part. Review the code. Experiment by adding a 0 division error with the feedback you can't divide by 0. Refer to the previous slide if needed. So yeah, let's see how did this work. Except it was 0 division error, if I remember correct. Yeah, with no spaces, which is that's what they said here, but they space it out. Except 0 division error colon print you can't divide by 0. Let's see if that did it. 0. Your code runs, but that's not quite the output we're looking for. Try checking instructions, and I'm betting it's a spacing thing or something. Except 0 division error colon. Let's go back and look at the last slide just to see exactly how they wrote it. That looks almost exactly the same. I'm gonna copy this and go here and see if I can see what the difference is. I'm gonna put it right below ours. Oh, they have an extra space in theirs. They shouldn't. Well, run. Huh. If I take that space out, I don't know. I don't see where where's the issue. I think ours is exactly correct, but it gets really weird sometimes. I'm gonna put that extra space in they had there and see if that works. No, it worked with an extra space. It shouldn't be spaced over that much. I didn't notice it back here. Oh, both of those are extra space. Well, Python doesn't care because we didn't put an extra space on ours over here. We had it back. I'm not sure it should be spaced over, but all right. Again, it gets real picky, and ours was exactly like that. But I wonder what other errors we could play with. Let's see, run program 6. Oh, anything else, we'd have to take out this line. Let's just to play with it a little bit. I'm gonna put comments and type 6. Hmm, invalid literal for it. We'd have to know what the name of this error is. I don't think we could type all of that to try to write our own message for that error. I'm just thought I would try it. No, that's not going to be the name of it. It'd have to have some variable name that's the error name that would mean this. So, okay, well, we can play around with that and figure out what that's called in Python and try to write a special sentence just for something like that. But that would take a bit more investigation, which we don't have time to do at the moment. How well do you know Python? By now, you've completed a few Python guided activities. You've written some code. You've even glanced through the reference section. How well do you really know? Let's take this quiz. All right, I'll open the chat. You just want to tap the chat. How do you indicate a block of code in Python? First, second, or third? You can just put 1, 2, or 3 and make it simple. You ask for a user to find input, you use a hash mark, or you indent each line by the same amount to indicate a block of code. Oh, I didn't really mean to select an answer. I was just highlighting there. But it's the first, second, or third, indicating this is a block of code. How do we let anyone know that? Yes, we indent each one. So whatever the block of code is indented. Like the main function would be indented, and this block of code is the main function. If we write another function, we would indent that. Indent it by the same amount. Ready? Yes. Okay. Next. What is the hash mark used for? Oh, that one we know. I'm going to go ahead and just put that one. That's the comments. We know that. Yes. I don't need a little hoorah after everyone. Which function does the hello world program use? The print, the type, or the string? Well, yeah, obviously we're printing hello world. We didn't use type or string or anything like that. So, which of these variables is written in camel case? We haven't used that word. We talked about it some in programming 1, but one of these variables is written in camel case. Yeah, phone number, or phone number, right? Yeah, we write variables in camel case, which means we don't capitalize the first word, but when there's multiple words, we capitalized all the successive words. Phone number, just to make that easy to read. This is not too bad, but still, this is real clear compared to this one. What is concatenation? Combining lists, combining strings, combining functions. Yeah, absolutely. Combining strings. We did that on print statements a lot last year. What is the proper syntax for a list in Python? Oh, that's a good one. There's not much difference between those. One uses the square brackets, one uses the parentheses, one uses the squiggly brackets. So, yes, we know a list, you guys are correct, uses the square bracket. And we learned last week or the week before that a dictionary uses the squiggly brackets. So, but you have to have a key, though. You got to have a key and a value for a dictionary. A dictionary in Python contains one value per. I was just talking about that. Per key. Yeah, just talked about that. And say using input in Python request data from who? Who has to give data when you use an input statement? The team, the programmer, or the user? Yeah, you guys got it. The user. And is the last one got a question? No, the last one's just our results. 8 out of 8. And that's it. And that's the end of it. This week, of course, when we go to our assignment, there's nothing there because we have a program to write this week. Let me put this up here. All right. Going to our classwork tab. It is there at the end of the lesson, of course. They have on page 5 the whole assignment. But when I make the template for you, you don't have to copy the template, because they have it. The assignment template is right there. And that's what I take, and I make an actual template in here for you. 1.04 template. Let's see what our program is this week. Choose one of the options provided below. So here's the first scenario. You're volunteering for an organization whose mission is to raise awareness in high schools about the impact of voting. They'd like you to build a program they can use at events. So this program should have a conversation with the user that asks them, okay, so conversation with the user. So we know we're going to have input statements. Ask them their current age, why they think voting is important, and tell them how many years until they can register to vote. In scenario 2, you can be creative and make up your own. Come up with any scenario for this assignment as long as you do the following. It must be about making the world a better place somehow. Must ensure people reading your code understand the scenario by you got to put the comments to tell what yours is doing, and follow the requirements described below. So here's our requirements. Algorithmic design. Use the algorithmic design stage of computational thinking to design a program. Well, that's really wordy. But remember, this breaks it down. The algorithmic design is where you create step-by-step instructions to solve a problem. It means you start with pseudocode, you translate it to Python, using your pseudocode as a guide, and then write your pseudocode where indicated below. It should be in plain English and indicate a conversation about improving the world. So you should write it in steps that reflect algorithm design. So you're going to write the pseudocode, and you're going to convert it. You're going to put comments in your code. And you're going to have at least 3 interactive prompts. So 3 input statements minimum. Could be more. Assign user input to variables that you can use later. Like you're going to need to use their age, ask because you need to figure out how many years until they can vote. And then print a tip on the importance of your selected topic. So if you're changing the world in some way, you're going to print why it's important to vote, why it's important to whatever you're doing. So here's example of expected output. Hello, Sammy. So you think voting is important because it allows people to have a voice in society? Obviously, that's what the user typed in. Good point. People can vote on many important issues, including global warming, taxes, and social issues. And since you're 14 years old now, you'll be able to vote in 4 years. So there's a little sample of what someone else's program did. Put your pseudocode right here. Got a little arrow. Write your pseudocode. Put it in the template. Use idle. You got to have comments, including a heading for name, date, and the description of the program. But remember, you can copy and paste a lot of your pseudocode for all that comments throughout the program. Use concatenation to join string literals, string values. Hint, print, this is a literal, string literal plus name, plus that was followed by a value in another. So it just reminds us how to do concatenation of putting strings together. Make sure you use indentation properly, use white space where needed to make it easier to read, extra blank lines and stuff, and run successfully. Produce output similar to that. You've completed writing your code. Save your work by selecting Save in Python idle. And when you submit your template, turn in this Python file. And we have our post-mortem review questions. So, all right. Any questions on what they're looking for this week? No, it's pretty straightforward. The voting one's good. If you want to choose something else besides voting, you have that option as well. But just something. And hopefully voting makes the world a better place. I guess it depends on who people vote for and how often. And sometimes voting makes things worse. I don't know. Yeah, we'll see. If everyone just votes themselves that I should just get a check from the government and not work. If we all voted for that, I don't think the world would be a better place because the government wouldn't have any money to give us because nobody's working and paying the government. Well, enough of the government political talk there. All right, guys. Program this week, and then we're going to finish up the module and take a test over what we've learned. I'm kind of liking some of this try and error stuff in there. That's kind of cool. I guess you can use that this week since you're having them put an age in. So if they don't put in a number, you can use that try except thing to say, that's not your age. It's not a number, so cool things. All right, guys, you got any problems? Oh, this is not a B day. So this week is an A-Day Friday. So I'll be here Wednesday and Friday this week if you need any help with your program. Otherwise, we'll see you next time.